Welcome and welcome, that's Dutch, to solving trigonometric equations. We're doing a number of problems here. The first one is 2 sine theta equals 1. So sine theta equals 1/2, or theta equals the inverse sine of 1/2. We know that the reference angle there is 30 degrees, and then of course we're in the second quadrant as well, so it's also 150 degrees. Already had prepared that beforehand, so I just pasted in here as the solution. That's what I just said a moment ago, and later on we'll be graphing and checking those. In fact, we'll be graphing this as 2 sine theta minus 1 equals 0, and then look for the x-intercepts. On the second one, we're going to come up with the following. I'm just going to copy this here and then repair it a little bit. So we're going to get the square root of 3 to the other side, add it, and divide by 2. So we're going to have square root of 3 over 2. We know that the reference angle to that one is 30 degrees. So there it is, 30 degrees in the first quadrant. And of course the cosine is also positive in the fourth quadrant, so the other solution is 330 degrees. And the third one is going to be 2 tangent plus 2. So we get the 2 to the other side. Let me just get rid of this here. Negative 2 to the other, we subtract 2, divide by 2, so we come up with tangent theta equals negative 1, or theta equals inverse tangent of negative 1. Reference angle is 45 degrees, but we're going to be in the second quadrant where the tangent is negative, so it's 135, and we're going to be in the fourth quadrant where the tangent is negative, so it's 315 degrees. This point here, I'm going to go over to the graphing calculator and check these solutions. So keep these in mind here: 30, 150, 30, 330, 135, 315 degrees. Okay. So let's see, y equals. The first one that we had was 2 sine minus 1, looking for the x-intercepts. I'm going to check the mode, degrees, that's fine, window, maybe the y I want to be negative 5 to 5 maybe. See what we get. And our solutions, as I had mentioned, would be 30 degrees and 150 degrees. Indeed, I put the scale at 30 degrees, and that's what you can see here. 30 degrees is the first one, and 60, 90, 120, 150 degrees is the second solution. Okay, the second one is 2 cosine minus the square root of 3. And graph that. And indeed, the first solution here comes out to 30 degrees. And the second solution right over here is 330 degrees. I guess I could graph it a little bit nicer, of making the y maximum here only at 2. And then, well, that looks a little bit nicer, I guess. 30 degrees is there, and there's the other one at 330 degrees. And the third example that we had is 2 tangent plus 2 graph that, see what we get. Okay, there's one solution, and there's the other solution. 30, 60, 90, 120, and then middle between 120 and 150. That's the 135, and over here, indeed, that's 315 degrees. So we did it correctly. I'll go back to the problems. Okay. I'll scroll down quite a bit here. Find all solutions between 0 and 360 degrees for 2 cosine theta minus 5 equals 3 cosine theta minus 2. On the graphing calculator, when I'm done, I will actually graph the left-hand side and the right-hand side and compare and see where they intersect. All right, so the way to do that, of course, is to subtract 2 cosine theta on both sides and add 2 to both sides. So I subtract 2 cosine theta on the right-hand side, which gives us a 1 cosine theta, which, of course, I don't need to write the 1. And then I add 2 on both sides, and I come up with -3. And as point, I don't need to go any further because I know that cannot exist, so no solutions. That means when I graph the original left-hand side and the original right-hand side, I should get no intersections on the graphing calculator. So let's do that. Okay, y equals the left-hand side, said 2 cosine -5, and the right-hand side said 3 cosine -2. Oops, I need to close the parentheses there. Let's see, the modem okay, the window, I think the window is all right. And then we'll graph, and let's see what we get. So there's the first one. Oops, unfortunately it's off the screen. And there's the second one. And I can make it look a little nicer by having both on the screen. So there we go. In any case, the two are not intersecting, and so the left-hand side and the right-hand side are not equal to each other at any angle, so we have no solution there. Okay, I'm going to actually try something here. I'm copying this and see if I can insert that right away into Word. Actually, that worked. There we go. So no intersections between left and right-hand sides, hence no solutions. Okay. Next problem. Solve for x. And this time around we're supposed to be between 0 and 2 pi. So we're supposed to come up with radians. So on this particular one, fortunately it's already factored, so I just need to look at the left parentheses, sine x equals 1. And the parentheses on the right is going to be sine x equals positive 1/2. Of course, you get the 1 over, add 1 and divide by 2, so 1/2. And then, of course, the solutions are x equals, sine x equals 1, there's only one, 90 degrees, or pi over 2. And then the other one, of course, this one here I changed to pi. There you go. And the other one is the reference angle comes out to 30 degrees and 150 degrees, but I'm in radians, so it's going to be pi over 6 and 5 pi over 6. By this time, I trust that you have them pretty much memorized, all those special angles and where the tangent and the cosine is negative and positive and so on, so that this one can go rather quick. Okay, this one here. Oh, now we encounter cosine and sine. We haven't come across that yet. That's really kind of a bummer. They just throw something new at us. However, it's actually really simple. Notice that both terms on the left-hand side have a cosine in them. So what do we do with it? Factor it out. Factor out cosine x. So as we do that, you're going to have cosine x times parentheses something equals 0. What do we have in parentheses? Well, after we factored out the cosine from the first one, notice that it doesn't vanish, but what is left behind is a 1. So because the important number in multiplying, dividing, which is also factoring, is 1, not 0. It doesn't vanish. And then when you factor out here, of course, here it's gone respectively. Keep in mind it's actually 1 that's left there, but we don't need to write that 1 down. Okay, so we're going to have, of course, for the solutions here, in order to get a 0 on the other side, we have cosine x equals 0. It's easily overlooked, but that is a solution. When the cosine is 0, we come up with a true statement, so that must be a solution. And the other one is going to be sine x equals, well, get the 2 sine x to the other side, divide by 2, so we kind of come up with 1/2. Okay, that pretty much means that the second solution here we already did a moment ago, that's going to come out to pi over 6 and 5 pi over 6, and the cosine equals 0 at 90 degrees, or pi over 2, and 270 degrees, or 3 pi over 2. So what I do is I just copy all of this here from the previous problem and put in here 3 pi over 2. And so this time around we come up with 4 solutions. The third problem that I have here, well, we have a quadratic equation. So we're going to do a substitution. The x is already taken up. What are we going to use? We'll use the u. U equals cosine of x. And then we plug that in. So we're going to come up with 2u squared plus u minus 1 equals 0. Quadratic equation will always work, but let me do the quicker way. Just maybe the factoring is going to work. If it's going to work, it would have to be a 2u in one of them and a u in the other one, and then one of them takes on a negative 1 and the other one takes on a positive 1. Let's see which one is correct. That will give me a negative u in the middle term, so I'm going to switch them around. I'm going to have here and when you FOIL this back here, of course, you're going to come up with 2u squared plus 2u minus u, so that's the plus u right here, and then, of course, minus 1. So that's why factoring here is correct. I can solve now for u, and then solve for the x by plugging in the cosine, or I can just plug in the cosine x right now, and that's what I'm going to do. Again, if it's a little bit off the screen, just scroll up. I'll do that right now. So here I plug in the cosine x, and here I plug in the cosine x. And then, of course, the two solutions are going to be cosine x equals, get the 1 to the other side, divide by 2, 1/2. And the other solution is cosine x equals negative 1. And that means we're going to come out with solutions. I'm just going to copy these here from the previous one and see what I come up with. These are not correct, of course, yet. 1/2 here, of course, the reference angle is 60 degrees. So we're going to come up with pi over 3. And then we're also supposed to be in the 4th quadrant since it's positive. So that's 300 degrees, or is it 5 pi? What is it? 5 pi over 3, right? 5 pi over 3. Even I have to think on these here. And then cosine x equals negative 1. That only happens once at 180 degrees, which is exactly pi. So I'm going to get rid of all of this here, and these are the correct solutions. Okay, and the last one. says the following. Use your graphing calculator to find the solution to the equation square root of 3 times tangent theta minus 2 sine theta tangent theta. And then finding the zeros to that. Well, that's what I've been doing all along, so we're going to do this here on the graphing calculator. Okay, there's still a one from the last time. Get rid of this, get rid of this, and now the problem says square root of 3 times tangent minus 2 sine tangent. Okay, I'm supposed to be in degrees. Okay, I am. Window setting 0 to 360 degrees, scale of 30. I'm not exactly sure. I'm just going to try here something -2 to 1 maybe. Actually, I did run a graphing calculator on the side here, kind of see what I need. So there we go. There's actually one solution already. There's another solution. There's yet another solution. And there's yet another solution. Oh, right there. Okay. I'm going to copy this one here, and we'll go over to back to the lecture, back to the problem section. Okay. Insert the graph here. Now this is truly off the screen. So solutions from looking at that, I've been using 30 degrees here for a scale, so the solution is going to be at 0 degrees. So I'm going to write theta equals 0, 60 degrees, 120, 180 degrees, and 360 degrees. Now I'm going to add these degree symbols there. And let's just look at a couple here and test them in our heads. 0 degrees, when I insert that, it's really easy because the first term is going to come out to 0, and of course the second term is going to come out to 0, and then 0 equals 0. Let's say try 60 degrees. We insert 60 degrees here. Tangent of 60 is the square root of 3 times the square root of 3 is a 3. So keep in mind the first term is 3. The second term is going to come out to 2 times square root of 3 over 2. So the 2's are canceling, so we have a square root of 3 here. And then we again have a square root of 3 over there, which means we subtract overall a 3 from the 3 up here, and we come up with 0. So 60 degrees is correct as well. And if you want to check the other ones, you know, it's in really the same mode that you would do that. And with that one, I'm concluding this problem section for solving trigonometric equations.